The world of temporary structures has a design problem. They can be compact, they can be easy to put up and take down, or they can be strong. But they can't usually be all three. Inflatable structures achieve 2 out of the 3. They can be quickly erected and flattened down again, but they're not very stable.
The problem with inflatable structures is that if you open the valve or if you puncture the structure, you have nothing preventing you from collapsing back down. So these systems are called monostable systems.
And failure of monostable systems can have disastrous consequences. So a team at Harvard decided to design a system for structures that are compact, transformable, and stable once they're up. To do this, they turned to the ancient art form of origami.
Origami have been around for a very, very long time in Asia. But the concept has been mostly explored by artists. But recently, scientists, engineers started looking at origami as a source of inspiration for a new structure that can fold, structure that can deploy. And I find this fascinating, like a form of art that has been around for a very long time can help pushing the boundary of science.
Specifically, the team began with one of the main building blocks of origami, the humble triangle.
What is powerful with origami as an art form is that we know that from a 2D sheet of paper, you can fold any 3D shape. So if you think of the triangle, we can arrange it in space with other triangles to make our first compatible state. Now, the trick is, can we rearrange these triangles in another way in order to form a completely different shape? And it turns out that if you choose your triangle carefully, you can do so. So you can find different states where all the triangles, they fit nicely together. We have these triangular faces connected on flexible hinges. So our goal is to figure out how to assemble these triangular faces in order to create a system that is bistable or even multi-stable. So bistable means you have 2 stable states on which or for which if you do not apply a force, it will stay there.
The team applied a mathematical tool based on a simple geometric principle that certain triangular angles stay the same in different positions within a sphere. Finding the angles at which triangles fit together in different positions allowed them to create bistable models of increasingly intricate shapes, flowers, starbursts, and even arches. They then used inflation to transform the models from one stable state to the other.
So we have this enclosure made of rigid faces that is folded super compact. You inflate it simply, so it's one inlet. You deploy it to a functional shape, and then you can remove pressure and it stays there deployed.
This ability to inflate the models all at once was the breakthrough that allowed the team to scale their technology. To date, most of the work on origami structures has been at a centimetre scale, but the team used their design to push the geometry of origami to new limits.
We really wanted to go much bigger than this. And this is where really we doubled the size, and now we really got to a very large scale structure that is about 2 meter high to really confirm that our bistability is only depending on geometry. It is scale independent.
The team's prototype pod features a transformable doorway, while the rigid panels offer more protection and better sound and heat barriers than standard tent fabric.
In the collapsed state, these are very flat. So you think of stacking multiple of these in order to bring them to the disaster site. And then you only need one operator and one pump to successfully inflate them. Once one is inflated, then you can release pressure and then go on to the next one.
Emergency shelters in disaster zones is one application, but this technology could also be used for flood barriers, changeable sound panels in concert halls, and even foldable satellites in space. And in architecture, Katja thinks it could be a helpful partner to traditional building materials, like concrete and bricks.
We want, for example, to better control energy into a system. We want to be able to control lights, heat, whatever. And maybe we can meet some of the new requirements that we would like this building to satisfy.
For David, this is just the beginning of a transformable origami world of customizable, multi-stable objects.
Say you want to have a bunny that transforms into a bird, and then you can inflate from one to the other, and then it's like Transformers, basically.
For now though, the team is excited to demonstrate how clever application of ancient art and high school geometry can change the world.
Coming into the project, I was not very familiar with origami. I guess like a lot of people, I was thinking of origami more as an art form. I was very surprised to see that it's actually a very powerful platform for engineering. I think what we've shown, what we've realized with this shelter is a practical application that is almost ready to be used for a meaningful task and to solve very important problems, I believe.